So as front-end developers, we have a lot of tools at our disposal to reach our users. And guess what? I'm here to add another tool to that already heavy tool belt. Now, the title and the agenda are in one slide, so that's a good save, I guess. So let's, well, if this guy wants to actually do what I'm, oops. Oh shit. Okay, that's a good way. That's a good way to start the conference talk, but I totally deserve it because I forgot to introduce myself. So my name is Radu Enuca. I do some web stuff and some management stuff at ING Tech Romania. Now, don't worry, I have these slides saved locally, or I should say cached locally. I mean, they work offline as well. Let's see. So before continuing, have you ever had this situation where you have a full signal, a huge waiting time, just to see the dinosaur? You know, this scenario, this is what I like to call Li-Fi. I mean, it's a totally unreliable experience, and if you say, yeah, I'm safe, I'm in Romania, I have 4G, no, you're not. I mean, you can have a sudden drop even in good network conditions. So again, unreliable experience, like this slide, we should have something on it, but don't worry. So I hope you all agree with me that we want our experiences with our apps to be reliable. And by reliable, I mean, first of all, just not show that stupid dinosaur. Show me something. Fail fast. Don't let me wait just to show me nothing. Again, be fast, open fast, be fast to be interactive, have smooth animations and scrolling. And be engaging, and I mean by that, have good interactivity, immersive user experience. So, what is the solution? Yeah, drum rolls. But a quick show of hands. Any Game of Thrones fans in the house? House of Vox Days, Bucharest. Okay, a lot. I know you guys are used to have your expectation crushed, so. Well, do you? I mean, what makes what makes native apps like the better or worse? We don't know. Let's have a quick view on the ways we can reach our users, and let's narrow down the, let's say, only on mobile phones, okay? Because those little guys are more and more connected to the internet, and we use them, basically, we have them with us all the time. So I'm not a native developer, so this is just my point of view. So let's see some advantages and disadvantages of native apps, for example. So they are clearly fast and responsive. You can distribute them in app stores. You can search for them. You have they access full platform features, and they can also work offline. On the other hand, you have multiple code bases. And here's first at Objective-C versus Swift and Java versus Kotlin. And because of multiple code bases, they don't get that cheap. What about web apps? Now, they are easy to build and maintain, assuming you keep yourself up to date with all the JavaScript landscape, okay, all the frameworks and everything. You have one code base, they get cheaper, but browsers. We have a lot of them, not everything is supported all the time. They cannot work offline and cannot access device features that well. So, what do? We take the best from one, we take the best from the other, we combine them, okay? Well, we end up with this. Built on web technology, you have one code base. You can access device APIs through wrappers like Cordova, for example. And you still have, they are not the same as native apps. And you might think I forgot about NativeScript, React Native, and Flutter from Google, which give you, let's say, native-like applications. Okay, so we have that. But there are still two things left, in my opinion. So One of them is high friction of mobile apps. So how do we get a mobile app on our phone? We open the App Store, we search for what we want, we click install, we accept permissions, it downloads. And again, if you have a high-end phone and high-speed internet, that will take, I don't know, maximum 2 minutes, 3 minutes, 5 minutes tops. But if you have to remove an app first to install the other one, or you have to do that on 3G, on slow 3G, that experience will take longer. And finally, you have your app on your phone, you open it, oh shit, it's a crappy app, I have to search for another. What about mobile websites, or the experience of mobile websites, the experience of what users have with mobile websites? So there are more and more devices connected, and I've seen a survey at some point. So during the month, you open like 100 websites or something like that on your mobile, and you install way fewer apps because after you install them, pretty stable, and you use those. But the experience with mobile websites is not yet there. There are a lot of websites that look totally crappy on mobile, and they are pretty hard to use. So, do I need a native app or not? And I will do the same thing as before, maybe. Now, you all know the saying that there is no silver bullet, one size fits all, or free lunch. Sorry, I'm hungry when I'm on stage. So you have to think for yourself, what exactly do you need to build? I mean, do you need to build the latest and greatest game with stunning graphics? And then not only do you have to build it as a native app, you have to target high-end devices. Do you need to build but what about if your application is content-based? I mean, an education app, a news app, a corporate website, a booking, or even a dating app. Do you need it to be on mobile, to be a native app? I mean, what exactly do you need to use from the device for those kind of apps? Also, do you need to reach users in countries where internet is a big problem, it costs a lot, or it's very slow, or they have low-end phones and they have to, every time they want to put something on their phone, they have to remove a bunch of other apps. So what we, let's say, end up with is something like websites that can behave nicely on mobile devices. They have full screen, they have a natural app navigation feeling. They work regardless of the Li-Fi that I showed you before. You can have push notification, or can be installed on your home screen and open with a shortcut. And something like mobile apps that can be discovered in search engines, so you can promote it with search engine marketing. You don't have to go to apps to update application after each content update. It's automatically done for you. You can also distribute it via web, because in the end it's on a website that can be linked. Finally, after we get to introduce the main subject of the presentation. Actually, they were not introduced. I'm not introducing them today. They are pretty old as the concept. They were introduced first in 2015 at Google I/O by Alex Russell and his colleague. But Alex says something interesting. Progressive web apps are just websites that took the right vitamins. Now, I tried to draw some nice vitamin complex stuff, but I ended up with this one. So these are the vitamins or the characteristics of a progressive web application. So as you can see, progressive, because it's in the name, it's also first one. So what that means is that the app will work for every user, regardless of the browser and regardless of the device, because they are built with progressive enhancement as at the core. So if you try to, this is how it looks like, okay? Next, they are responsive. So we are in 2019. I don't have to explain what that means, I guess, but basically they work on all form factors that are in existence and yet to emerge. They work offline. And not only offline, but they are connectivity independent. So if my slide building skills are up to date. Okay, so I have 4 examples for you here. So first is a Starbucks app, which just shows you that you are offline. You can browse, you can even add stuff to, if you want to order, you can add it to the checkout menu. Next one is a Google I/O app, where not only that you work offline, but you can modify your schedule, and at the moment your device regains connectivity, that schedule will be pushed to the server side and persisted. And then you have the Twitter Lite app, which it uses like an app shell-like design, and yeah, while offline you cannot search for tweets and you get a default offline view. And the other one is a bus scheduling app from India, where they just show you a default offline page. Now, here this can be also a missed opportunity, because the default offline page is an HTML page. So why not show a cross-source puzzle or a simple game to keep your user inside the app until the connectivity is back on? Now, also there are app-like. So here is an example of Santa Tracker. It's still an application made by Google. Now my video editing skills are way too bad. But you can see here how I install it on my device. It has a splash screen. It's a full screen app. Yeah, and at some point you get to edit those Santa helpers. They're also fresh, and that means the content is updated automatically without you having to update the app manually. Now, they're also secure, and again, in 2019, if you're not using HTTPS, that's your mantra. Repeat it 100 times, write it, I don't know. Joking aside, if you're not on HTTPS, you don't have a progressive web app, so that's a mandatory thing to have. Now, I already explained that they are discoverable. You can search them on Google, on your preferred search engine. They are recognizable as applications because of the W3C manifest file, and you can install them on your apps, on your home screen. They're also re-engageable, so that means receiving web push notifications. Unfortunately, not available yet on all devices, so for iOS, that's a no-no. And they are installable, So here you have 2 samples, one from an Android phone, where you get the install banner, and the second is a workaround on an iPhone, because that's not an install banner, that's just a picture that is centered there to tell you what to do manually in order to install it. So you have to click the share button and add it manually to your home screen. And again, linkable. Yeah, there are websites, so I just send you a link. You open it. If you like it, you install it. Otherwise, you discard it. And yeah, as I said in the beginning, I'm here to show you a tool, not to sell you one. So there are limitations. So until iOS version 11.3, which I guess it was last year, somewhere Q3 or Q4, I don't remember exactly, we didn't have service workers on iPhones. So there were no PWAs, basically. Now, of course, iOS is the bad guy here, because there are no web push notifications. They have their own implementation, but it's not the same. You have limited access to some hardware components of some devices. And yeah, basically, if you're on Android and Chrome, you're safe, but that's not the only device there. So finally, juicy stuff. What are the technical components of a progressive web app? So I will not say anything again about HTTPS. I'm pretty sure that's totally clear. So we have service worker and the manifest JSON file. Now let's start with the easiest one, the web app manifest. So this is just a JSON file that describes your app, telling it to the mobile browser how to use the information inside to create an APK file that will be your installable package. So a minimum manifest JSON look like this. So you have a name, have a short name for smaller screens. You need to have those two icons on those two sizes, and the browser will scale it for you depending on the device size. Of course, if you want to go pixel perfect, you can specify them in increments of 48 by 48 or something like that. Then let's go down. So you have the display, so you can choose if you want a full screen or you want to just have a search bar or show the browser. You can specify a background and a theme color and so on. This is how it looks like if you open the developer tools in Chrome, for example. As you see, I started with 48 by 48, and they go down, way down. And this is how you tell the browser to load this. So it's a link tag with the attribute Rails set to manifest, and then you have the file. Now, because of browsers, and because you have to be, the first word progressive, you have to support a lot of them. So not all the browsers are able to use the manifest file to read from it entirely. So you have to provide a lot of extra fallback meta tags for all those browsers. So you can do it manually, or you can use a tool called PWA compat that does it for you. So basically, you have to do this for Safari, but again, you can have older browsers or forks of browsers, or if you want that thing for IE, which I have no idea what that means. Spin sites, I think, is something that appears somewhere here at the top. Now, this is the main actor of a progressive service worker. And the service worker is just, let's say, a JavaScript file that runs in a different thread than your website. And not only that, but it can run even if your browser is not open. You know, every time you install a browser, you have some processes in your operating system that are running all the time. There is there where the service worker live. So they are basically proxies for your page. So they sit in between the page and the network, and they can also access the cache when they need be and stuff like that. So let's have a quick look of what they can and what they cannot do. So they can totally dominate the network traffic. So if you want to send back pink unicorns for every image fetch, you get that. They can access the cache. They can receive push notification. They can receive push messages from the push service for each browser, and they can show the notifications. And they also continue if offline. There is a feature called background sync, where if when you regain connectivity, a user agent will trigger an event for the service worker, and then there you could, read from an IndexedDB database and post all your data that was saved offline to the server. What they cannot do is access the window. They cannot access the DOM, because first they are in a different thread, and what they cannot also do is work on HTTP, as I said. For example, in Chrome, if you are under HTTP, you don't even have the object in DOM. There is no service navigator there. So they have a life cycle. So basically, you register them, and when you open the page, they are registered, and they are in a phase called installing. In this phase, you can do pre-caching. So let's say you want to cache your app shell and the first route, and every time you're offline, you get that from the cache. Now, if something fails, the service worker becomes redundant, so you need to fix it before it gets installed. After it's installed, it's waiting to be activated. So first, in the activating phase, you can clean up after the previous service worker. So let's say the first version of the service worker created cache version 1. You come with cache version 2. You delete the old stuff and create a new. Again, if this fails, it's redundant. So it is active and listening after it passed the activated phase. Now, how do you register a service worker? And first of all, this is how you check if you have service worker supported. So as I said, if you are in HTTP, this will be false. I don't know if all the browsers do that, but for Chrome, this is the... And how do you do it is basically register a file. You can name it as you want. It's just a JavaScript file. And yeah, you can do something with the registration later, but this is just how to register it. Now, service worker will answer to a couple of events, or not a couple, there are 6. I already explained install and activate. Message is when you want to communicate from your page to the service worker, like you do, for example, for web workers. You have to post a message, and you have a chance to respond back on the same callback. Fetch is for every resource fetch that your browser does, also for your API calls. The thing here is that if you want to catch API calls, you have to do them with the fetch API and not with XML HTTP requests. So if you do use a library like Axios that has XML HTTP requests behind, you cannot cache those. Sync and push are triggered by I call it a user agent. It's a software agent that runs for your browser. So when you regain connectivity, so you're offline and gain connectivity, a sync event will be triggered. The push will be triggered via the push service. And if we have time, we can have a look at all that process. There are 2 more events related to push, but this is how you listen to events. And there are 4 things here that I have to explain. First is this self object. This refers to the service worker instance. Then you have this event wait until, which basically tells the user engine, hey, keep my service worker alive until all the promises inside are resolved. Then you have the self skip waiting, which is basically, you know what, I don't want to wait for you to install me, for the user to close the app, and I just want to take over the world at this moment. And again, in the activate event, you have self.clients.claim. The way a service worker is activated after it's installed, you have to close the tab with your app and open it again. Or you can do that. As I know, I take all your clients, I'm the boss now. Whew. Now, a quick glimpse of how a service worker looks like. First of all, in order to have a service worker be a new version of a service worker, you have to change the file. And what's the easiest way to change the file is to have a version there that you increment every time you change something. Then I have, let's say, I have here an array of resources I would like to pre-cache. And then in the install event, I use this caches open to get or create a cache. And then I just add all of those values in it. I skip waiting, and that's it. Now, if I want to clean up, then, well, I'm doing some weird things there, but basically, give me all the caches minus the ones that I already created, because I don't want to delete those as well, and delete everything. And then in the fetch event, this is one way to do it. So what I do here is, first I look in the cache. If I have something, I just give it to you. If not, I do a fetch on the network. And if that fails as well, I will just give you a default offline page. This is what is called the cache strategy. And we will quickly see, because I don't want to show that much code. You'll see several of them. So this is the previous one. So I do a fetch request, service worker looks in the cache, nothing in the cache. I go to the network succeeds, user is happy. Or I can have this situation where I answer with the offline page. So the code is more or less the same. Now, it gets hairy. What about, I want to trigger a request, but I want to have a race between the cache and the network. well, you cannot. It will be cheating if you have the cache respond immediately, because if there is something in the cache, you just get it and the network will lose. So you have like a rabbit and the turtle race. A rabbit will wait a little bit, let's say 3 seconds before it responds. So this is the only usage I had for promise.race. I mean, if you have another one, I would love to hear it. But so basically, you trigger those requests at the same time with a delay for the cache, of course, and whichever answers first, you get a response. Now, I'm not going to show all the code from now on, but what I wanted you to see that it starts to become bigger and bigger. Okay, this is just a stupid function name. There is nothing like that in the browser. You have to implement it yourself. Now, what about this one? This one is something like, okay, I'll go to the cache, I give you what's in the cache, but in the meantime, I keep the service worker alive that will do a fetch on the network. When that responds, I don't care because I already give the answer back to the page. But I will take the new response from the server, I will put it in the cache. Next time, where you hit the cache, you will get new content. Again, and it becomes, well, a little bit bigger. But what about if I want to do this? Now, I also want to update the cache, but depending which one is faster, do that and the other one. And we end up with this guy, because the code will become bigger and bigger. And the problem is that what I had before is for every fetch that I do, not for APIs. For APIs, images, static resources, whatever I have in there. But what if you want to have different caching strategy for different resources? Things will get messy pretty fast. So this is a nice library developed by Google called Workbox, which basically does the whole stale while revalidate in one line. It works with routes, so you can register routes for different resources. So if we take the lower, the one below, see for everything that's in static, use stale while revalidate. That's just one line. I had like 10, I guess. What about, API calls? So, well, let's say I want a network to time out in 3 seconds, and more than that, I also want to have an expiration, which I didn't have before. But with plugins in Workbox, you could do that pretty easily. Okay. Do we have, how much time we have? I don't know how I started. Are there any questions so far? Shoot.
We don't have a microphone, right?
Can we have a microphone? Yeah, I can come closer.
In one of the previous slides, you showed like the fastest strategy for pulling in data.
Yes, yes.
So you basically pull from the cache first. So it's cache first, right? Then network, the cache, and then re-update the app.
No. Next time when you next time around.
Good. My question is this: does the network fetch happen in parallel with
Yes, because
the cache pulling, or are they sequential?
Well, first of all, the service worker will give you back the answer to the page, and then with the event wait until, it will stay alive to finish the fetch request and update the cache. And next, so he will just keep waiting for that stuff to finish, and the next time you hit the same resource and hit the cache, you get a new update.
So it's not something that's blocking, like
No, you're on a different thread anyway. Yeah.
different thread.
Yeah. Yeah. Okay.
So actually, in addition to his question, because you said these run in a race condition in parallel, right? So hitting the cache and hitting the server, right? And whichever transfers, but the cache is local to the browser. This is a JavaScript program that runs on your machine.
Yeah.
So is there even any point in having this race condition ever? It's never going to, the network is never going to finish first. Right?
No, because I'm delaying the cache. I'm delaying the cache like 3 seconds. So if the network actually responds or fails, because it can fail in less than 3 seconds, and then I don't want to have the offline page yet. I just, okay, network failed, less than 3 seconds, look in the cache and give me what I have in there. If I have something, if not, then fail. Exactly, yeah. This is a solution, for example, for the Li-Fi situation. No? So you have a sudden drop in connectivity, and you have a sudden drop in connectivity. The next call will take too long, but you already have it cached, so you answer from the cache. Yes?
So now that I'm such a knowledgeable user, I will refresh a lot because I think that the cache is responding instead of the website.
Yes.
I will refresh even more.
Hopefully you're not refreshing the wait Emacs filters. Yeah.
I don't. Do we have a couple of minutes? Because I want to show you, so unless somebody stops me or you guys want to leave, I have a show you quick about background sync. So this is when you are offline, and you can still trigger fetch calls to the server. Let's say you want to fill a form and you want to post it, you're offline. So what you do, you can save it to IndexedDB. That's an in-browser database. And yeah, you can show to the user a message, hey, your data was saved, and it will be synced later when you are online. Now, you can close the page, close the app, whatever. When the device regains connectivity, the service worker will receive a sync event, and there you can go and look in the cache, see what you have in there, and do the fetch there. Now, I will not step through the code because it's way too much. Again, doing by hand, you will have the slides, so if you want to look. But what I want to go is to this guy, because in the previous slides, I have to do something in the client. I also have to do something in the service worker. But with this, I could say, you know what? For every fetch that fails, put it in that queue. And yeah, just do it. I mean, it's, again, 3 lines of code. What happens is basically what I explained. If your fetch fails, then you put it in the queue that created above, and it handles everything. Yes.
But isn't the request consumed?
No, because I'm cloning it. That was the next topic I wanted to say. You work with streams here.
Oh yeah, so you clone the first.
Yeah, exactly. Exactly.
The original one.
Yes. Yes. So you have to clone it because it's both the request and the response will be streams. Do we still have time for this? Nobody's answering, so I'll go quickly over it. So how do you do it in the browser? So first you have to ask, you check if the user is subscribed. You ask the user to subscribe, which is basically asking for permission. And the user subscribes, you send the subscription back to the server, and server saves the subscription. Now, well, it's not that simple. First of all, you have to register the service worker. After you get the registration, you subscribe, which you send a message to a push service, which is different for each browser. And you get back, I'll show you in a second how it looks like, and then you save it to your server, you save it in the database, basically. This is how it looks like. The first one is from Chrome, and the second one is from Edge. So it looks like that. Now, the thing is that if I have that, I can send you push notifications, because those are public endpoints in the end. So they need to be secured. How do you send back trigger push from the server? You basically cycle through all your saved subscriptions. You do a post to the push service. You have endpoint there already. Then the push event is triggered in the service worker, which will just display a message, display notification. Now, what I want to show you is this. Let me just, so you have to search for it. You have to check if it's supported, of course. Otherwise, it's pointless to have it. Then you ask for permissions like notification.request permission, and then you save it. So if you don't have a subscription, you subscribe. So here you have an application secret server key, and there are two keys, public and private, of course. When you subscribe, you use the public key, but when you want to send push notifications from the server side, you have to use those both the public and server. And the protocol is called VAPID. And my memory is just refusing to recall it. It's voluntary application something. Oh. So on the service worker, yeah, I will not go over all of this. So this is how you send. So there is a web push. I'm using some Node package here, but there are implementations for Java, C# and other languages, of course. I'm using this web push package, which allows you to also generate the keys, and you get the public and yeah, the sending of this is pretty straightforward. So you just send a notification. You can, of course, send additional data with the notification. So yesterday we had an workshop for about this, about progressive web apps, and this was one of the code labs. So what was the main app that we had there is like a selfies app. Okay, so you take a selfie, then it's saved on the server side, and then you get a notification with the picture that was taken and the image. Of course, the support for this is totally different on browsers and on different operating systems. So I think at this moment the best look is in Windows 10. All the other, I mean, on Macs, you just get a tiny thing showing up, so you don't see the images that you put. In Windows 10, it looks pretty nice. Now, I don't think I have something, or I think Mikhail will speak about this after lunch, so I will not. Basically, you can access a lot of hardware from the device. So in the workshop, we have something to access the camera, and if you are on mobile, you can actually say, I want the front camera and the location. But again, there are a lot of differences between browsers, even between the same browser on the same device. For example, on Safari on an iPhone, if you are in the browser, you get access to the front camera on the camera. But the moment you save it as install it as a progressive web app, you don't. So they take that away. So you have to fall back to a file upload. For example, the geolocation stuff works in both cases. So there are a lot of fallbacks that you have to do. Yeah, I think I can stop here. I was that guy, hopefully still will be, so thank you very much for attending.